Understanding tornado lifespans. Most tornadoes are short-lived. The average tornado lasts only 10 to 15 minutes and travels less than 10 miles. These tornadoes form when a rotating column of air inside a thunderstorm, called a mesocyclone, stretches downward to the ground. Once the storm weakens or moves into less favorable conditions, the tornado usually dissipates. However, some tornadoes last hours instead of minutes. These long-lived tornadoes form within large, stable supercell thunderstorms that continue to supply them with energy. Meteorologists measure how long a tornado stays on the ground using its path length. If a tornado covers over 50 miles, it is considered unusually persistent. A few historic tornadoes have carved paths of 200 miles or more, leaving a trail of destruction across multiple states. The Tri-State Tornado, 1925. The Tri-State Tornado is the most legendary example of a long-lasting tornado. It struck on March 18, 1925, and tore across Missouri, Illinois, and Indiana. This tornado stayed on the ground for an astonishing 3 hours and 30 minutes, traveling about 219 miles. It is believed to have reached wind speeds of up to 300 miles per hour, 480 kilometers per hour, which would classify it as an EF5 on today's enhanced Fujita scale. The tornado killed 695 people and injured over 2,000, making it the deadliest tornado in U.S. history. One reason for its catastrophic impact was its forward speed, moving at nearly 70 miles per hour, 113 kilometers per hour, which left little time for people to find shelter. The Tri-State Tornado remains a key case study for meteorologists, although some debate whether it was truly one continuous tornado or a series of tornadoes from the same supercell. Either way, it demonstrated how devastating a long-track tornado can be. The Ellington-Parsons Tornado, 1953. Another historic long-lived tornado was the Ellington-Parsons Tornado, which struck parts of Texas and Kansas on May 2, 1953. This tornado remained on the ground for about 2 hours and 30 minutes, covering over 100 miles. It claimed the lives of 94 people and caused extensive damage to homes, farms, and towns. The event revealed serious gaps in tornado warning systems at the time. Many communities had little or no advance warning, which contributed to the high death toll. The disaster helped push forward the development of better forecasting tools and public safety measures. Tornadoes of the 2011 super outbreak. The 2011 super outbreak is one of the largest tornado outbreaks ever recorded in the United States. Over a few days in April 2011, more than 360 tornadoes formed across multiple states. Among them were several long-track violent tornadoes. The most notable was the Hackleburg-Phil Campbell tornado in Alabama. This EF5 tornado remained on the ground for 132 miles, 212 kilometers, and lasted about 2 hours. It killed 72 people and destroyed thousands of buildings. The outbreak as a whole caused over 300 fatalities and billions of dollars in damage. It also underscored how certain large-scale weather patterns can produce multiple long-lived tornadoes in a short period, overwhelming emergency services. The Hallam Tornado, 2004. The Hallam Tornado, which struck Nebraska on May 22, 2004, is remembered for both its size and longevity. At its peak, it grew to a record-breaking 2.5 miles wide, making it one of the widest tornadoes ever documented. The tornado stayed on the ground for about 1 hour and 36 minutes and traveled 52 miles, tearing through several communities. Although it wasn't as long-lived as some others, its massive width caused widespread destruction. The Hallam event proved that tornadoes can persist for long stretches of time while growing to extraordinary sizes. The El Reno Tornado, 2013. While not as long-lasting as the Tri-State or Hackleburg tornadoes, the El Reno Tornado in Oklahoma is famous for its extreme size and power. It formed on May 31, 2013, and reached a record width of 2.6 miles, making it the widest tornado in history. It remained on the ground for about 40 minutes and reached wind speeds exceeding 295 miles per hour. Despite its relatively shorter duration, it posed a serious danger, especially to storm chasers. Its unpredictable movement and immense size made it difficult to escape. The El Reno tornado showed that even shorter-lived tornadoes can be devastating. Key factors behind long-lived tornadoes. Meteorologists have identified several conditions that make a tornado more likely to last for hours. Persistent supercells. Long-track tornadoes typically come from slow-moving or stable supercell thunderstorms that provide a steady rotating updraft. Strong wind shear. A sharp change in wind speed and direction with height helps sustain the tornado's rotation. Constant supply of warm, moist air. Tornadoes need energy. When the atmosphere continuously feeds them warm, humid air, they can persist longer. Flat terrain. Flat, unobstructed land allows tornadoes to maintain their strength without interference from hills or mountains. These factors often come together in the central United States, which is why this region, often called Tornado Alley, is home to many of history's long-lasting tornadoes, advances in tracking and warning systems. In the early 20th century, especially during events like the tri-state tornado, there were no Doppler radars or advanced warning networks. People often didn't know a tornado was approaching until it was too late. Today, modern technology has dramatically improved our ability to detect and track tornadoes. Doppler radar can detect rotation inside a thunderstorm before a tornado even forms. Satellite data and computer models allow meteorologists to forecast environments that are favorable for long-lived tornadoes days in advance. Trained storm spotters and chasers provide real-time reports that help confirm warnings. These tools have saved countless lives by giving people more time to take shelter, especially during long-track tornado events. Climate change and tornado patterns researchers are still investigating how climate change might affect tornado behavior. While the total annual number of tornadoes hasn't significantly increased, there's evidence that tornado-prone areas may be shifting eastward in the United States. Additionally, some studies suggest that tornado outbreaks, periods when many tornadoes occur in a short time, may be happening more often. It's not yet clear whether climate change will result in more long-lived tornadoes, but understanding these shifts is crucial for improving preparedness in at-risk regions. Lessons from the past. Each of these historic tornadoes has taught us something important. The tri-state tornado revealed the catastrophic potential of long-track storms. The Ellington-Parsons event showed the need for early warnings. The 2011 super outbreak highlighted how weather systems can spawn multiple long-lasting tornadoes. The Hallam and El Reno tornadoes demonstrated that size doesn't always equal duration, but can magnify destruction. By learning from these events, meteorologists continue to improve forecasting techniques, building codes, and public safety measures. The continuing challenge. Despite advances in technology, long-lived tornadoes remain among the most dangerous natural disasters. Their extended lifespans mean they can cross entire counties and even states, overwhelming emergency response systems. Communities in tornado-prone areas must remain vigilant, with strong warning systems and disaster response plans in place. Continued research into the atmospheric conditions that create these massive storms is vital for reducing future loss of life.